Would you like to see my favorite equation in all of physics? You've probably seen it before, but it's not, you don't get it the way I do. It's kind of a niche understanding. F equals ma, Newton's second law. Honestly, Newton kind of nailed it by the second. I don't know why you bothered with the third. As a reminder, the first law is basically that things don't change unless there's a force. And the third law is if you have two bodies and they act on each other, then you're going to get an equal and opposite force. You know, tit for tat, eye for an eye, you hit me, I hit you, and call you ugly. I don't think Newton put it quite like that. Anyway, no, I'm serious. This is my favorite equation. I'm going to explain why. It's everywhere, and I mean everywhere. And despite being so useful, it's so universal that it basically comes up across all of classical physics. So let's say we have this here. This is the centripetal acceleration. Basically, if you're moving in a circle, then you've got to be accelerating towards the center of that circle at AC to be able to keep going. Basically, right, nice and simple. Everyone loves that. Now, the centripetal force, or the force that we need to make sure we're pulling towards the center to make sure we keep going round and round and round, then that's just F equals ma. So we get this new equation for the centripetal force, again, just from this very basic understanding. But what if you're a planet? What is the force? Well, the force comes from gravity. So we have this equation here. The force from gravity is equal to the gravitational constant times mass. That's the mass of you or the planet or whatever. And big M, typically that's like the sun or the earth if little m is the moon, for example. And then of course little r squared, very important, we have r squared. We can then say these are equivalent and rewrite this in the F equals ma way. So we have this lovely expression here, which we're then going to simplify a bit. And so we end up with this really nice equation here. This is the speed of an orbital body in a circle, depending on its radius and the mass of that central thing. And this is the cool bit about physics. We now know that the velocity that something is moving to stay in that circular orbit doesn't depend on the mass of the thing that's doing the orbiting. And then we can actually substitute in for V. I'm going to skip just past this, but basically using F equals ma and some basic facts we know about the universe, we can then prove this, which is called Kepler's third law. Basically just that the period of orbit squared is proportional to the radius cubed. And this is everywhere in physics. If you want me to talk a bit more and go through other derivations, let me know. But I love stuff like this in physics. I love that we can just use and abuse things that we found in previous experiments or previous answers and studies, and then prove new exciting things for us to test. Maybe we find that F equals ma doesn't work. Looking at you, Einstein. But I'll leave that for another day. Anyway, I hope you have a lovely day. Okay, bye.